Dear students, let us continue our learning the course Data Structures and Applications. We are in the second session of the module 4. The topics covered under this session are representation of trees. Myself, Dr. Suresh from the Department of Computer Science and Engineering of Canara Engineering College, Bantwad, Mangaluru. So in the last class, we learned the different terminologies which are used in the trees. The terminologies like node, root, child, ancestors, descendants, level, and the other things we have learned. So let us continue our learning on the trees. So in this session, we primarily focus on the representation of trees. So there are several ways to represent a tree. So one such example has been given over here, wherein the node of the tree is A, that is root of the tree is A. A is having three children, B, C and the D. B is having the two children, E and the F. E is having the two children, K and the L. C is having a single children, G. D is having three children, H, I and the J. H is having a single children, M. So if we go to the level of the tree, so A is there at the level 1, B, C and the D, they are there at the level 2, E, F, G, H, I and the J, they are there at the level 3, and K, L and the M, they are there at the level 4. Here, A is the root node and the leaf nodes are K, L, F, G, M, I and the J. Right? So now let us go for the different ways of representing this tree. There are primarily three ways are there for the representation of the tree. The first one is list representation. Second one is left child right sibling representation. The third one is representation as a degree 2 tree. So let us go in depth one by one. First, list representation. For a list representation, we are going to use a singly linked list is used for the representation of the tree. The second one, left child, right sibling representation. So child and the parent relationship we have learned already. If I take the example, A is the parent of B, C and the D. So out of which B is the left child, C is the immediate right of the right sibling of the B and D is the right sibling of the C. Fine. So now for B, the siblings are C and the D. In the same way, for E, B is the parent, E is the left child, and F is the sibling of E. So that will be the your sibling representation. And the next one will be the representation as a degree 2 tree. The degree we learned already the number of a child the each node will have. For the A, it has 3 children, so the degree of A is 3. Next, for B, it has the 2 children, so the degree of B is 2. C as a single children, the degree of C is 1. D is have the 3 children, so the degree of D is 3. E is having the 2 children, the degree will be 2. F don't have any children, so the degree is 0. H don't have any children, the degree is 0. And H is having a single children, so the degree is 1. I don't have any children, so degree is 0. H don't have any children, the degree is 0. The next K don't have any children, the degree is 0. The next L don't have any children, so the degree is 0. So this is what the degree of the nodes. So this degree 2 tree means a maximum of 2 degrees we can have. Maximum of 2 degree means 2 children we used to have. So we will rearrange the elements so that we can represent them as a degree 2. Right? So that is the third representation, that is representation as a degree 2 tree. Let us learn one by one in detail. First one, the list representation. The list representation will be for the figure which has been shown in the A is represented as First, the root node will be the entire tree. If we take up for this figure A, the entire tree, let me write in one parenthesis. First, have a root node. The root node is A. Fine. So now the A has three children over here. So if I take up the A has the three children. That is, the first one is a B. Then the next one is a C. Then the next one is a D. If I go with the B again have the two children. They are E and the F. E and the F. It has the two children, E and the F. Next, if I go with the E is having the two children over here. The children for the E are K and the L. F don't have any children. Next, C is having a single children. That is a G and a D. D is having the three children over there again. So that is a H, I and the J. So again, if I take up the H has a single children, that is M. So this representation, fine. So this representation will be your tree. So now this tree we need to represent. This tree we need to represent. So for the representation, for representing this tree in the list representation, if we continue, it will be represented by, first we start up with the root node A. We start up with the root node A and we create the list for it. So how many elements, how many nodes I will connect? I will connect whatever the number of children the A will have. So in this case, A is having the three children over here. So I will have the three nodes over there. The node number 1 for the first child, node number 2 for the second child, and node number 3 for the third child. Node number 3 for the third child. So now for the last child, the link of the last child, I will make it as a 0. That is a null value over there. Fine. So now I will go with the first child. For the first child, if we take, the first child is our B. The first child of A is our B. So now for the B. So how many children does the B is having? B is having the two children over there. So we will have the two nodes over there. The first node and the second node. The first node is again it is a tree. So again there will be a link. The second node will be your F. So F don't have any child. So we will stop at the F. That is F and the link field will be made as a 0. Then next, the child of the B. The child of the B is your E. So E if we take up again for the E is again having the two children over there. So again E is having the two children. The children are, the first one is a K. The first one is a K and the second one K and the second one is a L. Second one is a L. So this completes the child, the subtree of the B. Then next we take up for the C. So now if we go with the C, again for the C is having a single children, that is your G. C is having a single children, that is your G. Fine. So in the same way we will write for the D. So this is our final result of the list representation over here. Fine. In the list representation, if you observe the list representation, tree node will have the two components over there. The first one will be your information and other is the link component over there. First will be the link information and the link component over there. In the link, in the information field, the child value will be written and it will be, if it is a again having the child, a list will be created over there. Right? This is how we go for representing the list representation. Fine. Then let us continue with the next representation. Then the next representation is left child right sibling representation. Then the next representation is a left child right sibling representation. So in this representation, each will have a data field, left child and a right sibling. So as you can observe over here, there are three components. One is the data field, left child, and the right part will be its sibling, not child. It is not a child over there. It is a right sibling. That's why it is known as a left child right sibling representation. Left child right sibling representation. To convert a tree into this representation, there are two steps are there. First, note that every node has at most one left child. That is the immediate, the left child we are going to take up. Then the second one, at most one closest right sibling. At most one closest right sibling. Fine. So let us learn how we are going to do this one. So now, in this case, the same tree has been taken again. First, we start off with the root node. Root node is A. Fine. Then next, the left child of the A. What is the left child of the A? The left child of the A is B. Left child of the A is B over there. Then next, towards its right side, we will write the right sibling. What are the siblings of B? One is C and the other one is D. Left child, this is left child right sibling representation. Left child and the right sibling representation. Then next for the B, if I take up the B, for the B what we have? We have the left child as E. Left child is E and right sibling. What is the sibling of E? Sibling of E is F. What is the sibling? Sibling means the children of the same parent. We call them as a sibling. Fine. Again next for the E. What is the child of the E? It is a K. Child of the E is a K. Then sibling of the K. What is the sibling of the K? It is a L. Sibling of the K is L. Then next F. F don't have any children. Then next will be your C. What is the left side of the C? Left side of the C is a G. Then next D. So D is having the three children. Take the first left child. What is the left child of D? The left child of D is H. Then sibling of H. What is the sibling of H? One is I. Other one is J. Then next, the left child of H. What is the left child of H? M. Right? So this is your left child right sibling representation. Fine. So first we write the immediate left child and we connect its siblings to the right side. We connect its siblings to the right side. This is the second representation what we have learned. The first one is a list representation. Second one is a left child right sibling representation. Let us continue. Then the next one is a representation as a degree 2 tree. Representation as a degree 2 tree over there. Means a maximum degree will be taken as 2. Maximum degree will be taken as a 2. So now let us take the same tree example. We will take the same tree example. First we start up with the root node. What is the root node over here? So first before that one let us read the description of it. To obtain the degree 2 representation of a tree, we have to simply rotate the right sibling pointers in a left child right sibling tree clockwise by 45 degrees. So we have to rotate the right sibling tree, left child right sibling tree by clockwise by 45 degrees we need to rotate. So if you go back to your previous one, this is your left child right sibling tree. So if I rotate this, how will I get that one? First will be my A. You have to rotate that one, fine. Then next will be my B. The right sibling you rotate by 45 degrees. Then next will be my C. You have to rotate by 45 degrees. Next D. Then next B to E. Its sibling you have to rotate by 45 degrees. So you rotate by 45 degrees. This will be your F. Then next it will be your K. You rotate by 45 degree. This will be your L. Then next for the D. For the D, if we take up, this will be, for the D, if we take up, this will be H. Rotate its sibling by 45 degree. That will be your I. Again you rotate its sibling. That is your J. Rotation by 45 degree. Then next for the H, the left child is a M. Right? This will be your which tree? That is a degree 2 tree. Right? So you can observe over here. The same thing you can get. Right? So that is in a degree 2 tree. It is a left child right sibling tree. You have to rotate clockwise by 45 degrees. So which is going to yield the degree 2 tree. So if you directly go for writing it, it's a simple concept. Either you can write the left child right sibling tree, and from there you can construct degree 2 tree. This is one method. And the second method, you can directly construct the degree 2 tree. So how to construct that one? First we start with the root node A. Then towards the left side you will have your left child, that is your B. Then next to the right side we will have your sibling, that is your C. To the left side we will have your left child. Always you towards the left will be your left child. Towards the right will be your towards the right child will be your sibling. So left child, left child of B is your E. Again for the E, to on the left side, on the right side you write your sibling, but the sibling of E, that is F. On the left side you write the left child of the E. What is the left child of the E? K. For the K, the right, you have to write its sibling. What is the sibling of the K? Sibling of the K is L. Right? Then next, for the C, what is the sibling of the, what is the sibling of the C? D. You have to write as the right child. What should be the left child of the C? Its own child. What is the child of the C? That is G. G should be its left child. Then for the D, for the left child, H. Right child, no sibling of the D. Closed. Then next for the H, what is the left, right side? Right side is sibling. What is the sibling of the H? Sibling of the H is I. Next, what is the sibling of the I? It is J. Next for the H, what is the left side of the H? It is M. Right? So even this will also will generate the degree 2 tree. Fine. So there are two ways we have discussed. One will be first we construct left child right sibling tree. Then we clockwise rotate by 45 degree. Then we clockwise rotate by 45 degree. That is one method. In the second method, what we have learned, first we write the left child. On the left we write its left child, and to the right we are going to write its sibling. To the right we are going to write its sibling. Right? So that is going to yield the degree 2 tree. That will yield the degree 2 tree. Fine. So these are the three representations for the trees. What are the three representations we have learned? The first one is a list representation. Second one is your left child right sibling representation. And the last one is degree 2 representation. Let us take one more example and let us try to solve that one. in the all the three representations. Let us try to solve. So let us take this example and we try to represent this tree in all the three representations. The first representation, the least representation. The first representation will be your least representation. In the least representation, first we start up with the A. That is your root node. A. A is having how many children? Two children over there. So we create the two attached nodes. Then next, it will have the two children. The first children, it is B. Again, B is having how many children? Two children over there. One is your D that don't have any children, so we'll directly write. Then next, one more is your F. Sorry, E. Again, if you go with the E, how many children does the E is having? E is having only one children, that is F. This is D. This is D. Fine. Then next, the second child of the A. Second child of the A is a C. So C is having a second child is your C. C is having how many children? C is having the two children over there. The first one is G and the second one is H. So H is again it is a subtree. The second one is your H. H is again a subtree. It is having two children again. For the two children, one is your J. One is my J. So J again it is having one more children, that is L. And the second child for the H is K. So this is the first representation. What this representation we call it as we call this representation as a list representation. We call this representation as a list representation. Then let's go with the second representation. For the second representation, the second representation is a left child right sibling representations. First we go with the A. Left child B. Right sibling, that is your C. Again for the B. Left child D. Right sibling is my E. Again for the D, I don't have anything. E, left child, F, right side sibling, I don't have the sibling. Then next for the C, left child is my G. Right sibling of the G is H. For the H, left child, J, sibling, K. Then next for the J, left child, L. Sibling, I don't have it. Fine. So this representation is a left child right sibling representation. Left child right sibling representation. Fine. So this is my left child right sibling representation. Then the next one is a degree 2 tree. Degree 2 tree. How to get that one? So start with the root node. Left child. You have to rotate this by 45 degree. So left child B. Right child of the B is its sibling. Sibling is C. Again for the B, left child D. Right side will be my sibling, that is E. For the E, left child is F. Then for the C, left child is G. Right? Then next, right for the C. For the G, right child is its sibling H. Then for the H, left child is my J. Left child is my J. Right is my sibling. What is the sibling? K. Again for the J, left child is L. So this is a degree 2 representation. This is a degree 2 representation. So this is how these are the three different ways of representing the trees. So what are the three different ways? The first one is a list representation. Second one is a left child right sibling representation, and the third one is a degree 2 tree. Right? So the references for this presentation are taken from the textbooks Ellis, Horowitz and Sartaj Saini, Fundamentals of Data Structures in C, second edition, Universities Press. Thank you.